Hey, and welcome back to the second episode of this Blender for Game Developers tutorial series. In the last episode, we covered navigation and basic modeling. And to review the navigation, it is middle mouse button to orbit, shift middle mouse button to pan, remove the camera around. Of course, you can do all these orthographic views with the numpad, and then selecting an object and pressing numpad period will focus on the selected object, and then home focuses on all of the objects in the scene. There are a few things I forgot to mention last episode. One of them was the N panel here. So it shows you, of course, you can open it with N, or you can just click that up top there. By the way, you can also hide this by pressing T. Again, N for the N panel. And it shows you the transform of whatever object you have selected, as well as the scale. Scale is really important because if you export an object that's not 1, 1, 1 with all the axes for the scale, like that, then you can have problems. So it's really important to apply, that's Control A, apply scale, and that will reset that all to 1, 1, 1. So there's a difference between scaling up an object in object mode, where this scale here changes in the end panel, versus going into edit mode, scaling up with all the faces selected, where it's still the same scale. That makes sense. Same thing's true in Pro Builder modeling for Unity, by the way. If you scale up an object using the Unity object tools versus selecting all the faces and then scaling up the object that way. One other thing I want to mention is that, well, I guess two other things. One is that if you ever have a problem where you get this issue where it's like clipping through the object, that's because of the clipping plane. So what you need to do is you can just take this and just drag it. You can click, hold, and then drag it down or left. And that should fix that issue. Final thing I want to mention before getting into materials is that when exporting, it's just File, Export, FBX, but there are a few extra things that you need to do. I'll link to a video that explains all of those. So now to go into materials. In this previous episode, we only worked within this one workspace. It's the layout. This is the default workspace. And you can see up here all these different tabs. All these different tabs are workspaces, and all they are is just different collections of windows. Remember, you can change each of these to whatever you want, that are just organized in a way that are more specialized for doing whatever it is that, they're labeled for doing. So we are going to go into the shading workspace, and there might be a file editor here. I just join the area, and you can also join that area too, because we're not going to use it. We're only going to use this, and a tiny bit of this. So as you can see here, there are these different tabs, and all of you need to know about right now is this materials one. It's this red sphere, and the default cube already comes with a material. In this material, you can see that there is this node in this editor, because Blender uses a node-based material editor, kind of similar to Unreal. And if you've ever used visual scripting, or if you're coming from VRChat and you've used the Udon programming language, you'll know that the dots here on the left of the nodes are inputs, and then the dots on the right of the node are outputs. So this principled BSDF, it is a physically based shader. It's a PBR shader. No, not like the beer. It stands for physically based rendering. And essentially, what a shader does, if you don't know, is it takes textures. A shader is a part of a material. A material takes textures combined with a shader to determine how an object should be shaded, how it should the surface of that object should interact with light. And what this principled BSDF is, as I said before, PBR, physically based shader. So it essentially lights in a way that's realistic. It's supposed to be true to life. And there are all these different parameters here. but the ones you only need to worry about if you're going for game design are the ones that you'll find in whatever engine you're using. So usually that's just base color, roughness, and normal, although some materials also include metallic maps, emission, or alpha as well. So all these other ones here, if you're not using Blender, you don't need to worry about all of them. I know it can look scary. And even if you're going to use Blender, you're not going to use all of these, probably. So since we already have our material here, what we want to do is we want to insert a texture. Blender comes with its own procedural textures. So to do that, we want to add a new node into this workspace here. Besides, before that, I forgot to mention, you can use the same shortcuts to move around in the 2D workspaces in Blender using 3D workspaces. So middle mouse button is to drag around, and then you can click and drag these nodes, unlike the 3D workspace, but you can also use G to grab them as well, in case you were wondering. And to add in a new node, it is Shift A. And you can see here, there's all these different ones. Usually I just do search, so you can either click or, remember, you see these underlines under the letters, so it's Shift A and then S to search. I want to search for a brick texture, and then press enter, and now we have a procedural texture in our workspace here. And we can just connect this so it's the color of this brick texture to the base color of the principled BSDF. And as you can see, well, if this is also using the same material, we have this brick texture applied to the surface of our models, all the models that are using this material. And as you can see, it looks a little off, right? And that's because of the projection. Get into that, but of course, you can edit some of these procedural textures however you wish, and obviously disconnect them like that. But remember how I told you to install Node Wrangler in the last episode? I'll go over it again in a bit, how to install it again. But if you did install it, there are some very useful shortcuts. The ones you'll probably use the most are Alt and middle mouse, and then that you see it's a lazy connect. So it takes this node, the node you have, connects it to the one you with that 2 lines there, and it automatically connects it to the one that you'll probably end up connecting it to. So it connects this first yellow one to the first yellow one of the receiving node, essentially this input to this yellow output. And there is control right click, which you can use to sever ties instead of having to, precisely do that. It's just a simpler way of connecting nodes together. Again, I'll go over how to install that in a minute. So as you can see, biggest problem we have with this right now is the projection. The projection is off. Why is the projection like this? To understand that, you have to understand UVs. I don't think they're always explained in the best way possible, so I'll try and explain it a way that I think might be more intuitive. The best way to think about them is to think about, well, a map. Because if you think about a map of the world, Earth, is spherical. It's technically not a sphere. It is, it's an irregular ellipsoid, but for simplicity's sake, we can say it's like a sphere, right? It is technically spherical. So to make a 2-dimensional map out of a 3-dimensional object, that requires some sort of projection. And same with 3D models is we take these 2-dimensional textures and then project them onto 3-dimensional models. And that the UV map is the in-between. It's how the 2D texture is projected onto the 3-dimensional surface. And if you're wondering why UV, well, that's because the coordinates X, Y, Z, and W are already used for other things in the 3D software. So U and V are, the next ones in the alphabet. And there are many different projections of the world. So the Mercator projection is one of the most common that probably all of us have seen, and this was made in 1569. And the reason it was so popular is because it preserves angles. So a right angle is going to be a right angle in the real world anywhere on this map. It demonstrates the problem of why you cannot perfectly project a three-dimensional object, the surface area of a three-dimensional object, onto a two-dimensional surface. And this orange peel problem demonstrates that, because if you try and take an orange, you cut it, you can't cut it in whatever way to flatten it out to make sure that you have, the least distortion possible. You can't make essentially a rectangular two-dimensional image or map out of a three-dimensional surface area. For example, the Mercator projection, one of the trade-offs it has to make for preserving angles is that it distorts the sizes of land masses by a significant margin. So if you look at the Mercator projection, Greenland looks roughly like the size of Africa. But if you look at a globe, Greenland is more than 14 times smaller. Africa is more than 14 times larger than Greenland. There are plenty of other projections that have come up since, because now using the Mercator projection or a two-dimensional map isn't the primary means of navigation, usually GPS, of course. So there are all these different kinds of maps which have their advantages. They try and specialize in something, but they always have to make some kind of trade-off. There always has to be some kind of sacrifice made. And essentially, when doing UV maps, the objective is to get the most density, so the most pixel density, because remember, an image is made up of pixels. So you want to get the most pixels you can out of a UV map, but you also want the least distortion possible. This is another way of thinking about the UV map is wrapping on chocolates, because it's a two-dimensional image or wrapper or whatever, and then it's wrapped around a three-dimensional object. So let's get back into that. So we actually have a workspace for that. It's the UV editing workspace. And at this top bar here, you can middle mouse, click and drag. What we can do is, you see here the surfaces are just flat. There's no texture to them. Well, if you click under this material thing, which remember, drag all the way to the right, under this drop down here, you can see this color. Instead of doing material, we can say it's coming from the texture. We can say that the shading is flat. Or if that doesn't work, oh right, because it doesn't work because we're using a procedural texture. So you actually have to go into viewport shading to see a preview of that here, because this is a procedural texture. But actually, we don't want to use a procedural texture. We want to use an image texture that'll help us a lot in this. So what we can do is we can create a new texture, and there are these generated texture types here. There's 3 of them, and we want to use color grid, because that's going to help us out a lot with seeing how different parts of our model are distorted by different UV projections. So we see this is the color grid here, and it will make it very easy to identify on our UV map. So instead of this brick texture here, you can instead click this. Remember, it's under this menu. You can click this, go to image texture, and then use the texture we just generated. And if we go back to here, remember, flat lighting texture is the color, we can see how the cube has a very nice, even projection, but this other model here doesn't, and that's because we edited the model, but we didn't edit the UVs. So it's using a cube projection on a surface which is clearly not a cube. If we look at the cube, you have to go into edit mode, and then you have to press A to select all of the faces. You can see them, and again, you can use the same shortcuts for the 2D views. And in this time, instead of the nodes, you can actually use R to rotate, S to scale, and of course you can use G to grab, and Control Z to undo as always, right? This is the projection for a cube, which is very standard. As you can see, it wraps and folds around, right? This is actually created in Blender, which is kind of funny. But so you can see that it's like there were cuts made to these different edges here that you use to unwrap. Same way as that, remember that orange peel problem, right? You have to cut up a three-dimensional model to essentially wrap it or to flatten it out. And that's essentially what UV mapping is. And it's hard to grasp at first, but it becomes more intuitive with practice. The easiest way to unwrap in Blender is to first select everything, and then the lazy way to unwrap is to go to the UV editor here and press U, and then Smart UV Project. All options are usually fine. Oh, and here's the thing, you have to either, you have to select them in both workspaces, or you can press this button up here, which will simultaneously select in both the 2D and 3D workspaces or windows. Smart UV Project, okay, and you can see now that there is a much better projection for this model. If we go back into the shading workspace, we can again have brick texture. We can lazy connect, oh, right. Well, it connects it to the next input there, right? So I just severed that, but lazy connect that, and you can see that now, well, yeah, it still doesn't look great. But if we were to use a PBR texture, you can see that, which we'll get to in a minute. But one of the things I want you to note is that what the default Blender Unwrapper does is it creates a bounding box around all of these different, they're called UV islands. And just as I said in the last video, you can use Control L to select these different islands here. So if you just select, say, this one face, you can then press Control L and it will select the rest of the faces on that island, and you move them around. You see it updating in real time in the 3D viewport. Again, scaling, and what you essentially want to do is have even density again, so that there's little distortion, but also the same amount of pixels, because that's what this texture is made up of, is a finite number of pixels, and you want them to be about the same given any, face's surface area of the model. One last thing before going back to the shading workspace is Shift A and then add in a UV sphere. Then we can move that to the side. We could make a new material, or we could make it the same material as the cube. And if you tab into edit mode, you can see how it's unwrapped. Basically the same way that this model was unwrapped. But again, it just demonstrates the kind of distortion you're going to get sometimes when unwrapping a 3D model into a two-dimensional surface. Very difficult to get a perfect unwrap, or to get a very, very ideal unwrap. So let's talk about PBR textures now. And for that, I would very highly recommend go to and install the Node Wrangler add-on. Remember, it's add-ons, and type Node Wrangler in there and click the checkbox. Because what we're going to do, first we have to go get a texture, and as of recording, there's an outage on the best texture site, ambientcg.com. So I'm just going to go to Polyhaven instead, click on textures, and choose this texture because it's somewhat shiny. It'll showcase some of the features of PBR well, and it has a pattern. It has wood planks there. So I don't need any more than 1K. And I actually want to show this as separate files. And now I want to download it, right? And so this is of course my downloads folder, and you have to right click, extract all, or if you have 7-zip, you can do it as easy as that. Very highly recommend 7-zip. Copy the address as text, go in there and disconnect, sever that connection, click on the principled BSDF. Again, I'm just saying this again because I've had people in the comments before tell me that they don't know how to do something even when I've explained it before in the video. So again, go to add-ons, edit preferences, add-ons, type in Node Wrangler, enable Node Wrangler. Because what it allows you to do with PBR Textures, instead of importing these one by one, hooking them up, it can do that for you. Control Shift T and then paste in that and go to the textures there and then principled texture setup. And it imports all of those PBR textures for you rather than you having to do it yourself. Made that smooth. So you can see some of the different attributes of physically based rendering and why in making realistic graphics or video games, PBR is really essential because you can see that sheen is different across the different parts of the material. You can see that there are bumps and ridges, even though this is just a flat two-dimensional face. So, very highly recommend using physically based textures, of course. And as you can see here, here's the projection for this weird 3D model we created. It's couldn't be better, I suppose. The other thing I'd like to say is that there is a UV add-on that's a lot better than the one that comes default with Blender. So that's this right here. It's uv-packer.com/blender. I'm not going to go over the installation process, but I have it in this older version of Blender here, which, by the way, something I also forgot to mention in the last video is you click on a face, you can control right click to extrude. Pretty cool, right? So I can select this and I can unwrap, I can smart UV project. That gives me this projection. And as you can see, it's not ideal because there's a lot of empty space here. And ideally in UV projections, you want all of this space to be taken up by different UV islands. You might be wondering, why isn't this UV island just inside of there, right? Well, that's because Blender's default unwrapper doesn't do concavity. So what you have is a bounding box, a rectangular bounding box around each one of these UV islands, and nothing else can be like inside of it, right? So to fix that, you have to use a different unwrapper, which is the one that after you download, you can have this UV packer. And as you can see, it gets a much denser pack for you. So I would very highly recommend using that one over Blender's default because of how much more efficiently it can pack, because of how much more we go up here, we can see that we want these, there, it's Control Shift Z. The redo shortcut is different in all these different softwares. But you want these letters on the grid to be as small as possible because that means you're getting more pixels out of the texture. So as you can see here, the pixels are about this big, but if we undo, you can see that the pixels were a lot bigger. And if you make the pixels smaller, then you're getting more texture detail, getting more bang for your buck, essentially. Pack that again, and we've only used Smart UV Project, so I'm going to leave you with how to do it custom, right? Because what you can do here is you can unwrap, but that won't do anything because you don't have any seams in the model. So you can make those cuts yourself. Remember the orange peel, right? So what you can do is you can click on edges. I'll control click to click all around and select that edge. And then I can press Control E to bring up the edge menu. That's the same menu as is here. And you can press Mark Seam, and that will make a red mark around the edges of your mesh. And what that'll do is if you go to unwrap, right, unwrap, you can see that it now unwraps. It cuts that edge, and that's how it's unwrapped. Now it's very, very distorted because this is not at all an ideal way to unwrap. An ideal way to unwrap is actually, it's kind of easy. It's pretty automated. Most of it's automated, and then you can go and make some edits yourself, is you can deselect everything. So Alt-A, select, and it is select sharp edges. Again, you can just press space or F3 to and type in select sharp edges if you ever forget. And this will select sharp edges at whatever angle you specify. 30 is pretty good. And with those edges selected, you can press Control E and then Mark Seam. And then go and select all the faces with A. Go back into this 2D editing UV workspace or window, and then press U to unwrap, and then unwrap. And that's a more custom way to unwrap. But of course, sometimes it's not always ideal. Like for instance, if you would want the texture to be continuous along this edge here, you would select that edge, you would press Control E and then clear seam. So now you can select all the edges or faces and unwrap again. Now you can see it's continuous across that edge. The select sharp edges goes well in tandem with shade auto smooth. If you go to shade auto smooth, shade it to be angle of 33, and if you select the texture, it's hard to see with this texture, right? But the shading is smooth along, for instance, this edge, so along these two faces, versus the shading gets harsh when it crosses over to that face. Hope you've learned about materials and texturing and UV maps in this tutorial. And I want to say big thank you to all of you patrons have helped me out a lot, because later today I'm going to go and buy and build myself a new computer, which was funded in large part by you, the patrons. So I'm going to sell my old computer and then build a new one with the Ryzen 7800 X3D chip, which is coming out today. It's supposed to be the best one for running a lot of games, especially the best bang for the buck, especially great for running Unity games, like for instance VR Chat, because it has a huge L3 cache. So hopefully I can like play in the pug with 60 FPS, but maybe that's still a pipe dream. Anyway, thank you so much. Hope you learned something. Give me feedback in the comments. It'd be really helpful. Tell me if you want to see a third version of this, more intermediate, that goes over things like topology or normals, editing normals, armatures, things of that. Again, thank you all so much. Till next time.